This is a lights-out shoe manufacturing cell, a factory that fits in a single room. For over a century, footwear has been built the same way: expensive metal molds, labor-intensive stitching, and supply chains that stretch halfway across the globe. It's a system optimized for making millions of the exact same thing. But that system is breaking. Between rising shipping costs, tariffs hitting record-high percentage, and consumers demanding custom fits, the industry is looking for an alternative. Some say 3D printing is the answer, but there is a massive gap between printing a cool prototype on a runway and printing 1 million pairs for the mass market. Today, we're going to look at the engineering reality and the specific economics of bridging that gap. At DHR Engineering, we recently ran a continuous 48-hour production stress test using our automated print farm of 44 FDM machines to see what it actually costs to make a pair of shoes in America. Let's break down the cost per pair. Low-end sneakers, sourced from factories in China, may start around $6.50 to $9 per pair, while better quality production typically lands closer to $25 ex-works. For new designs, tooling costs add up quickly. Injection-molded footwear requires a separate mold per size, typically around $1,400 each. But once you add shipping, customs, and significant tariffs, large minimum order quantity, and the risk of holding inventory that might not sell, the landed cost skyrockets. During the automated test run, the cost to produce a finished pair locally, accounting for materials, electricity, machine depreciation, and operator labor, came out to $15.42. That puts local digital manufacturing within striking distance of traditional mass production. But how do you get that price that low? The biggest cost driver in the West is labor. If humans have to manually scrape shoes off a build plate every few hours, the math falls apart. The solution isn't just better printers, it's better process engineering. To hit that $15.42 price point, you need 3 specific automation pillars. First, robotic tending. A single robot manages the entire fleet, loading and unloading 24/7. This allows one human operator to manage a factory of 44 machines with just 1 hour of work per day. Second, centralized control. A software brain that routes jobs. If a printer fails, the system knows instantly and reroutes the task. There is no downtime waiting for a supervisor to notice a red light. And third, automated post-processing. Taking the shoe off the printer is only step 1. Post-processing, like washing, curing, and finishing, must be hands-off, or your factory just becomes a bottlenecked prototyping lab. We've seen big players try this before. The Adidas Speed Factory is a famous cautionary tale. But their mistake wasn't the technology, it was the strategy. They tried to use robots to do human tasks like lacing and stitching. The future isn't automating old workflows. The industry lesson is now clear. True efficiency comes from redesigning the product for automation, not just automating old workflows. This unlocks things traditional factories can't do, like mass customization. Because there are no molds, it costs the same amount to print 1,000 identical shoes as it does to print 1,000 unique shoes based on iPhone LiDAR scans of your feet. Companies like Zellerfeld exemplify this shift by offering custom-fitted footwear. The transition from prototype to product is no longer a technology problem, it's a systems engineering problem. When you combine generative design, localized production, and full-stack automation, you don't just get a cool shoe. You get a supply chain that is faster, cheaper, and, because these mono materials can be ground down and reprinted, infinitely more sustainable. The factory of the future isn't a massive complex overseas. It's a farm of machines right next door.
That's all.